Today I am explaining our C activity topic is time response and board plot analysis system. We are using the MATLAB simulink for the time response and board plot analysis. We have present our group members is Srirang Power, Rohit Shinde, Sai Rane, Gurjit Kaur Sandhu. Our guide is for C activities Dr. G.B. Vijay Kumar sir. After that, in the introduction and system overview, in the system overview, we have used the second order control system by taking the function of g of s is equal to 4 upon s square plus 2s upon 10. For this function, we have used the c of s is equal to r of s upon 1 plus r of s for the solving the equations. Our main objective of the activity is to analyze the time response, analyze the frequency domain response by the board plot. We use the preference for the MATLAB simulink because it is a very easy source to analyze the time domain response according to it. After that, time domain analysis means step response. The step response must be categorized into the means it has important characteristics as a rise time, settling time, overshoot time. Overshoot. The rise time is the output taking the time for the desired uh, reaching to desired value. Settling time is the time to stabilize the time limits. Overshoot is how much time is required for the desired value of output. The settle time always must be plus or minus 5% to the plus or minus 2 to 5%. It helps to understand how the speed response system stability under time or over time. In the graph, we can see easily how to increase the settling time. Then the graph is showing the waveform according to it under time, over time, and critical damping values by the maximum signal at level. Thank you.
Hello, sir. Our topic is time response and board plot analysis of the system. I am explaining a frequency domain analysis. It is also called as a board plot. Frequency domain analysis means board plot represent the system response in terms of frequency. It consists of a magnitude plot and phase plot. Magnitude, the graph of magnitude plot in gain versus frequency, and the phase plot graph in phase versus frequency. It is used to analyze the stability and robustness of the system. The key parameter of the board plot is the phase margin and gain margin, and it is generated using a MATLAB function like a board and margin. Then correlation and conclusion. The time domain and frequency domain analysis are the interrelated. Higher phase margin is result in a lower overshoot. Then higher bandwidth leads to the fastest system response. Step response explain the time behavior, and the while board plot explain the frequency behavior. Then MATLAB Simulink provides an effective platform for the analysis and the visualization. Then both the methods together ensures the better understanding of the system performance and the stability. Thank you.
Hello everyone, I'm Ms. Gucci, and today I'm going to explain a MATLAB program used to analyze in a control system. So first we will define the transfer function, which is g of s is equals to 4 upon s square plus 2s plus 10, where numerator is equals to 4, we have taken it in an array, and denominator is equals to 1 to 10, that is also in array. So system is equals to transfer function of numerator and denominator. Then we will take the transfer response. Then transfer response shows how the system reacts to a certain input. We plot it using the step function, and also we will see the some of the characteristics of it. So first and foremost, in the step info function system, to find the characteristics, we have used the rise time which indicates how the system rise time, which indicates how fast the system responds. Settling time indicates how it takes time takes to be stable, and short time shows how much output exceeds the final value. Then afterwards, we have also taken the Bode plot analysis. Here we have take some of the margins. So first and foremost, the Bode plot of represent the frequency response of the system. Using magnitude and phase plots, it helps us to understand how the system behaves at different frequency. Finally, we have taken the margins to calculate the stability margin, to calculate the stability of the system, that is the stability margin, including gain margin and phase margin, along with the cross frequency and parameters. Then also these parameters help us to determine the stability of the system. In conclusion, So now we will see the Bode plot analysis. The Bode plot analysis present the frequency response of the system using magnitude and phase plots. It helps us to understand how system behaves at different frequency. Finally, we will see the margin functions to calculate the stability margins, including the gain margin and phase margin. Then also we will see along across the frequency, gain across the frequency, and also we'll see the phase across crossover frequency. So these parameters help us to understand the stability of the system. In conclusion, this MATLAB program allows us to understand the analysis of time response, frequency response, and also overall stability of the control system. Now we will see the output of the system. So yeah, the command window we can see the detailing, and two figures will be there. One of them is for the Bode plot and one is for the time response. So the figure 2 shows the Bode plot of the system in which magnitude is taken in decibel and the phase is taken in the degree, which are against or versus the frequency which is taken in rad per second. And in the first figure, we can see the time response of the system in which magnitude and time seconds are against each other. So thank you so much. This were the MATLAB program explanation.
Hello, sir. Good evening. So my name is Shrang Power, and today I'm going to explain the output of the MATLAB program for the control system analysis. And here is the program which has been explained by one of the groupmate, and now I will explain its output. So just to run this program, we'll run it in the MATLAB and we will get the output. So it will give the two figures in which the output is being divided into two parts, that is step response and the Bode plot. So first of all, the step response output. So talking about the step response output, which is the figure 1, in the first using the step of this we get the step response graph, and this graph shows how the system output changes with the time. So here we can see that using step of this we can get the output that changes with the time. And initially the output rises quickly and shows a fast response, and then it goes on oscillating, or then it goes above the final value, and this is the overshoot, and after that it oscillates and then settles, which is the settling time. Here we can see this, the increase, the oscillations, and the settling of the graph. So using the step info of this, we get the rise time, setting time, and the overshoot. So from this graph, we conclude that the system is under damped and stable. Moving forward to the Bode plot. So the Bode plot has the magnitude plot, that is the gain versus frequency, the phase plot, which is the phase versus frequency. Which both are in the respect to the frequency, and the gain decreases as the frequency increases. And also one more important point, that the phase moves towards the 180 degree. So using the margin of this, we get the margin and the phase margin. So from this we conclude that the system is stable and with good phase margin. So finally, from the both graphs, we conclude that the system is stable, slightly oscillatory, and has a moderate speed of response. So in simple, about talking about the entire output of the program and topic. So in this activity, we analyze a control system using the MATLAB by studying the both time domain and the frequency domain responses. The step response help us to understand how the system behaves with the time, and while the Bode plot helped us analyze its stability using the frequency response. And from both the analysis, we conclude that the system is stable, slightly underdamped, and has a moderate speed of response. Also, we observe the time domain and frequency domain parameters which are related, and which helps in better understanding and designing control system. So this was all about the conclusion on outcome of the activity. So thank you.